G'day team, my name's Ty and I'm a senior developer on the Jade platform. I'm also the lead developer of the database component, although since I started in Jade support many years ago, I'm kind of a jack of all trades. For example, I used to deal with all OpenSSL support. So when the time came to expand TLS coverage to all of our network connections, I was the perfect candidate to design its replacement. JadeSSL is our integration with Microsoft Secure Channel, or S-Channel, using Microsoft's Security Provider API. And I'm going to take you through some of the features and design philosophy behind it, as well as show you a few operational or management steps that will fall outside the scope of our implementation. At various stages, I'll contrast JadeSSL with our implementation of OpenSSL. And please, my comments on OpenSSL are mainly to do with how we chose to integrate with it. There's nothing fundamentally wrong with OpenSSL itself, if you're into that kind of thing. Anyway, on to JadeSSL. JadeSSL is here to create secure, private connections. It's not here to do any operational management at all. There are specialized tools in the operating system for that, and we will leave all of that kerfuffle to them. They're better at it anyway. This means you get to keep using industry standard tools and don't have to work out how to do the same thing through Jade. So what is the design philosophy behind JadeSSL? Well, the overarching philosophy is to be as easy as possible for users. It might sound trite, and surely everybody strives for this, but it really was baked in from the very beginning. To configure OpenSSL, there were about 100 different settings to get just right, and you needed special network rules. Well, maybe not 100, but it may as well have been. You had to configure all of these guys, along with my personal favorite, SSL cipher names. You ever seen a list like this? And you had to change it every time they added or removed ciphers. And don't even get me started on managing the certificate files you had to have just lying around. And even when that was all right, sometimes you'd get incomprehensible error messages put out in the logs that even I needed to delve into the source code of OpenSSL to attempt to understand. This made it hard to use for me, and even harder for anyone else. And if there's one thing we've learned about encryption as an industry, it's that if you make it hard to do, people won't do it. To turn on JadeSSL, in contrast, really only need two settings. One to tell us where to find the configuration file, I'll get to that, and one to turn it on. There's no SSL port to configure because you've already spent the time and effort configuring your network connections and firewalls, and I just want you to turn the feature on and be secure. Here, I'll show you. This is my Jade any file. As you can see, under the JadeSSL section, there's the configuration store setting. This points to the file containing your JadeSSL configuration options. It could be this file if you want, but the thinking was that since certificates are installed in the Windows Certificate Store, which is system-wide, multiple Jade systems on the same computer could probably just use the same configuration file. Since we're going to be testing an SDS connection, I've actually got both my primary and secondary Jade any files pointing to the same JadeSSL any file as evidence. Now this is the JadeSSL config file. This is literally all that's required to make encryption work, although we'll do better in a moment. I've set it to SDS, but we won't start Jade up just yet. Something else I provided is a program called SSL Configuration Tool, so you can test your configuration without having to start Jade up and work out which logs to look in. Now I'm a little bit short of time, so I've cheated a little bit and prepared some commands already. These are documented. We're going to use SSL Configuration Tool to read the configuration files and attempt to make a secure connection in the same way that Jade would. If there are any issues, we can look at the logs and sort them out. Now, any connection basically has two ends. So while we could use this tool to act as both ends of the connection at the same time, we'll pretend that we're talking across machines and start it up twice. Once as a server, and once as a client. Well, that was successful. It's attempted to set up a secure connection, and it's told us that an encrypted connection has been successfully initialized. Now, if we go over to the server, it's also got a note for us that says it found a certificate to try, and it's listed the name on that certificate. The reason it said it found a certificate to try is that we didn't tell it in our SSL config to use a particular certificate. So Jade made a guess. That's just to get developers up and running quickly. JadeSSL will look at the first potentially suitable certificate and try that. For a real system, we don't want to be guessing anything. So let's put the name in and have a go. So that was the name on the certificate. And I'll just go over to my template file here. Put the setting in. All right. Let's run it again. First the server. And now the client. Excellent. An encrypted connection was successfully initialized with no nodes. Now, ordinarily, for external-facing systems, you won't have a computer name on the certificate. You'll have a list of DNS names that clients use to connect with, and that's great. JadeSSL will tell S-Channel to perform server authentication using the subject alt names as well, because that's what they're for. So the SSL config tool has gone into our Jade any file, read where the configuration store is, it's gone to the configuration store, it's looked at the type of connection we're starting, and it's gone and associated that, or found the section that that's associated with. So when Jade starts up an SDS connection, it will read that section too, and we can have confidence that we'll be successful. For example, I'll start my SDS system up now. Let's start the primary. And the secondary. And check the John message log. Oof. And just down at the bottom where it's telling us about connecting to the primary, it's telling us that an encrypted connection has been initialized. So excellent, everything just worked. Well, what happens when we misconfigure things? Hopefully, the most common misconfiguration errors are covered in the solutions provided. For example, after you install the certificate into the certificate store, you'll need to give the user account that Jade is running as read access to the certificate's private key. I had mine all set up, but let's see what would have happened if I'd forgotten. Open up MMC, the Microsoft Management Console. Look at the certificate management for the local computer. And in the personal store, you can see my certificate right here. So I'll right click, all tasks, manage private keys. Go to me and take away read access. Now let's run these again. Start the server. Start the client. Lots of errors. If we were running Jade, this output would be in the John message logs or the Jade HTTP logs, depending on which connection type we're using. For this kind of error, the client output isn't that useful. All it shows is that a connection couldn't be established, because when you're using JadeSSL and you've told it to make a secure connection, if it can't, we're not going to connect. So let's look at the output from the server, because that's where the error actually was. It's attempted to set up a secure connection, and acquire credentials handle, whatever that is, failed with some number. This here, acquire credentials handle, is the specific function that failed, and here is the specific error code that it failed with. You can look that up on MSDN and see what it means when it returns that error code. Now, in these scenarios, when we're setting things up, it's all due to misconfiguration anyway. So while you won't have perfect knowledge, you can make an educated guess. In this case, I've written something useful out for you. Probable cause, the user requires read access to the certificate private key. Well, that is the error we were expecting. So that's excellent. Before we progress, let me re-enable read access. And I only need read access. There we are. I'll be able to make secure connections again. So once we've made a secure connection, how do we know it's secure? Well, there's an indication in the logs. It does say an encrypted connection was successfully initialized. And that's a good start. But how do we check? Well, there's only one real way, and that's to inspect the packets themselves. So let me start Jade up in single user mode. Okay. What I've got here is a small server client application, and we're going to use the opportunistic TLS support I put in to show the difference between secure and insecure connections. Opportunistic TLS, or OTLS, is the preferred way of sending emails securely to mail providers like Microsoft Exchange and a few others. Card Schema's email framework uses our OTLS support, so it's all done for you that way. I have to add a section to the SSL config file to tell it to use OTLS. So we will bring that up. Here we go. Go to my template. So I've added a new section called Office 365 Settings. And I need to add that over there. And I noticed the name of the connection that the application was using was mail. Could have been anything. So I'll just add that there. Make sure that matches, and I'll bring Jade back up. All right. Now we'll tell Wireshark to start recording. So it's going to record every network packet that crosses my machine. Up we go with Jade. Tell it to set the connection type name. Listen for incoming connections on the server and connect to that server, and Wireshark jumps into life, as we can see. Now, let's send something memorable to the client. So there we go. If you have a look in Wireshark, it might not be visible on your screen, but we can see here the user data itself says something memorable. We've been able to read it straight off the wire. And in the client, we've received something memorable. Well, with opportunistic TLS, we can just turn the security on. So let's do that. Good, the connection's secure, and you can see the Wireshark has registered some TLS handshake packets. Let's send something even more memorable to the client this time. And the packet that just arrived down here, you can see in the user data section that well, it's encrypted. And that's just what we want, really. So what connections do we support encryption over? Well, app servers, fat clients, those connections to the database are all supported. Primaries, secondaries, those are supported. Any web service running inside IIS is supported, so that's anything using Jade HTTP to the web application itself. ODBC connections are supported, both thin and fat client modes. And where you've made a .NET application using a .NET exposure, that's supported as well as opportunistic TLS, which I've just explained. In Jade 2025, we've added support for direct web services in the base release and WebSockets as well. And scheduled for a service pack is support for JSM deployments for SDS and client nodes. And we haven't currently scheduled support for the presentation client, TCP IP connection class, or the Apache web server. The thin client and the TCP IP connection class were already protected by OpenSSL, so they got bumped to the end of the list. I've got a good news story for you now. So encryption adds an overhead. In general, it's not a very noticeable overhead. Your mileage may vary. But during development, after I plumbed the secure connection infrastructure into the connection between the client node and the database server, say an app server or a fat client, that kind of thing, I tried to start Jade up, and the experience was not conducive to rapid development, shall we say. I don't remember how many minutes the IDE took to start up, but it was more than 0, which isn't great for productivity or morale. Now, this was about the 5th or so connection I'd plumbed JadeSSL into, and I'd never seen anything like this slowdown before. It was unusable. Obviously, a bit of profiling was in order, and we discovered several issues which were slowing down the performance of the client node to the database server TCP connection, which this new encryption was exacerbating. Firstly, and least excitingly, there was the freshly obsolete RPC encryption. There is a confusing any file setting which references both OpenSSL encryption between the presentation client and the app server, and the same setting name in a different section also adds a type of encryption between the client node and the database server. This meant we were doubly encrypting things, just for extra security. And there was a particular calculation in there which took up quite a lot of time. Well, thankfully, that's irrelevant now because we have TLS and has been disabled. The big issue we discovered was a bottleneck receiving messages on the client node from the database server. Only one message could be received at a time, no matter how many applications you had running on the client node. In fact, generally your performance would degrade in proportion to the number of applications you had running. Imagine all of your applications waiting eagerly at the front door for their packages, but the mailman just slowly slides each letter through the slot, one at a time. Anyway, that took a lot of work, but it's fixed in Jade 2025. Each application has its own mailbox and can talk as much as it wants to the database server. This is a huge improvement for every application on a client node using TCP, not just those using TLS. We haven't performed final benchmarking, but the initial benchmarking results, if I recall, show that applications on a TCP client node on the same machine as the DB server could see similar performance to HPSM, which obviously raised a few red flags. So we went looking and found something in HPSM that could be improved as well, which is also scheduled for 2025. Why do I bring these up? Well, it's good to share good news, but they're a direct result of the new development that we invested in. We wanted end-to-end encryption, and we got that and a significant performance boost for everyone.